Welcome into the Tech Ed Podcast. My name is Matt Kirkner. I am your host for this episode and every single episode of the Tech Ed Podcast. Our parent company, the Tech Ed Media Group, recently released a report on the state of artificial intelligence, in this case, in the state of Wisconsin, which is where we are headquartered, but certainly lessons in that report for anyone around the globe interested in artificial intelligence. Two things we found as we went through the research for that report, and by the way, we'll link that up in the show notes for anybody who's interested in getting access to that report. Two things that we found that were particularly interesting and pertinent to today's episode were this. Number one, when we look at the sectors that our survey participants expected to be most disrupted by artificial intelligence, the second item on the list was advanced manufacturing, or the manufacturing sector. I'll let you access the report to hear the first item on the list, but number two was the manufacturing sector. When we talked with those participants about the biggest impediment to implementing artificial intelligence in manufacturing, the number one impediment was their ability to identify use cases. In other words, everybody knows that AI is going to disrupt manufacturing. Everybody knows that AI is something they need to be working on, but they are unsure about where to start, unsure about what use cases within their organization would be the best place to start. Today's guest is someone who offers a perfect answer to that. I met Nitin Ranjan probably several months ago, maybe a year ago. What his company Golgix is doing, and he, by the way, is the founder and CEO of that company, really, really fascinating in terms of creating turnkey solutions for manufacturers interested in applying artificial intelligence. This is going to be a great episode for anybody working in manufacturing, especially those small to mid-sized manufacturers trying to figure out where to start on AI, and for all of our educators who tune in every single week wanting to know what's going on in the world of advanced manufacturing as it relates to artificial intelligence and how we prepare the next generation of the workforce. So live in the studio is Nitin Ranjan. And Nitin, thank you so much for joining me on the Tech Ed Podcast.
It's a pleasure being here.
Now, you've got a tremendous background in artificial intelligence, awesome background in technology. You're putting that background to work now in your company, Golgix. How is AI right now being applied in manufacturing as you look at the manufacturing landscape?
I think, AI is the buzzword. Everybody is talking about it. I think that's the word used in a C-suite a lot these days. In manufacturing, I would like to say AI as a technology is open source, and it doesn't really have an intrinsic value until it's applied. So you have to see where are you getting the most amount of data, right? Mm-hmm. And in a manufacturing, all the way from procuring a raw material to the way they ship out final goods, you have data coming through from there. We are applying AI specifically on the plant floor. And the use cases, as you said, has been the challenging part of our manufacturers. But what we have seen is solving yield issues, productivity issues, and throughput are the three top use cases. Those three things, if you solve for those three things of using AI and there is enough data to support that use case, you can really deliver some great business value to manufacturers.
Absolutely. Well, and I think manufacturers a lot of times don't give themselves credit for how much the incredible amount of data that they have available to them. Is it your sense that most of them aren't collecting the data in a way that's actionable, or where is the challenge and the biggest challenge there?
I think it's a perception problem than the data problem. I think they believe they don't have the data, which can help solve the problem. And I think that is the mindset which we are trying to solve, because the reality is they have the data to solve the problem. It's just buried under tons of other data set. A PLC, which is a heartbeat of a manufacturing, programmable logic controllers, helps automate the machines. They collect ton of data. Automation engineers already know that, but they don't know how to use that for intelligence. So you need technologies like AI to interpret their data fast enough to get them to value.
So for our listeners who may not be totally attuned to all of the lingo of manufacturing, of course, a PLC, or as you suggest, programmable logic controller, you call it the heartbeat of manufacturing. Sometimes I refer to it as the computer of manufacturing. I mean, It really is every single manufacturing process that you can envision, that you've ever seen on how it's made, that you've ever seen on a manufacturing plant floor. A really, really good chance, if that's something that's come of age in the last 50 years, there's a programmable logic controller behind that, gathering inputs from the manufacturing process, information from sensors and switches and so on, and then activating output devices that maybe maintain the temperature of a tank, maybe control a piece of manufacturing equipment like a punch press, something like that. So you've got all of these programmable logic controllers, all of these computers of manufacturing gathering some information. Since we're here in Wisconsin and right across the street from the Rockwell Automation plant. I'll use their name as a Rockwell Automation, Allen Bradley, a brand that many of our listeners might be familiar with, but there's others, Siemens, Omron, Mitsubishi, lots of folks that make programmable logic controllers. So what you're telling me is that as I'm talking to a manufacturer who doesn't maybe have an appreciation for the data that's available to them, rather than maybe looking at the sensor level of the sensors that are gathering information, those sensors are sending data to the computer of manufacturing, the heartbeat of manufacturing, the programmable logic controller, in a way that we can utilize that data in an AI application. Is that what I'm hearing?
Yeah, like we have built a very simple API. All we need is the IP address for that PLC, and we can suck all the data out.
Okay, so you basically created a platform that allows you to integrate with any data source. Let's talk about what happens there, and let's think about, if I'm thinking maybe food production, or I'm thinking maybe tier 1 or tier 2 automotive production, to building parts for cars that our listeners might be familiar with, applications like that. Let's take an example. Which one's better, the food one or the vehicle one?
I'll talk about both of them, but let's just start with assembly.
Okay, great. So we have a manufacturing operation that is assembling a part for a car. So it's manufacturing this part. How does this work?
Yeah, so you have assembly lines. Say you have 23 different stations. Each station has a unique activity they do. Either they will, slap two valves together, or put a component and apply some force to fit it into the cavity. Any of those assembly process is unique to each of those stations. For the stations to work in tandem with each other, you need PLCs to program that.
Okay.
Now, each of these stations will collect things like the amount of units go past through them, at what rate they go past through them, how many are good, how many are bad, what SKU ID, so what type of unique ID for that assembly serial number is. All of that information is already captured in the PLC. Okay. Because you need that for traceability, programming, whatnot.
Sure.
We are interpreting that data to understand whenever you lose, you have too many rejects, that is, your yield is going down, first pass yield. What is it? What's the leading indicator for that? PLCs already see that, already captured that type of information. It's just under a log. So whenever something bad is going on, you have 10,000 entries every minute coming in. So humanly, it's impossible to interpret that data.
Sure.
And this data has been there with us for the last 40 years.
So what are some of the other things? I mean, you got every single minute 10,000 pieces of data coming at you. Some of the things you mentioned, like cycle time, like throughput, like yield, and so on. What are some of the more obscure types of data that you might be gathering on a PLC that people might not even realize is being recorded or noted there?
I think one thing which has been very eye opener for even for us has been that the PLC actually records your assembly serial number. That might not mean much to people, but when you train an AI model, if you don't give them categorical variable to understand for this particular valve or for this particular use case, you have a different type of operation. Okay. You will generalize the AI predictions and AI outputs, not getting the good accuracy for your process. Okay. So that is why getting that level of categorical data already being logged in the PLC is been really key in giving specific, precise prediction, but to provide them the confidence, right? So if you think about the classic use case of speed loss, meaning if the cycle time, by the time a human notices cycle time, it has to be at least above 6 seconds, like a second more than what it typically takes. Okay. You don't catch 0.2, 0.25. Right. And that's where you start to lose 10% of your throughput. Sure. Using PLC dataset, because it's sampled at such a high frequency, you're able to get that level of movement in the data. Got it. And then so you've got all these, in some cases, all kinds of input devices, whether it's a positioning sensor, it's a light sensor, it's a temperature sensor, concurrent with the obvious data of what was the SKU maybe, or the specific part number that was running through the piece of equipment, or how long did it take for that operation to be completed. Yes. You also have all this other disparate data that's being collected at the PLC level. Yep. that is actionable if we know how to compound it and how to use it and how to analyze it. How to interpret. Yeah. I think you just moved into the continuous process here, manufacturing process, where food, right? For example, they capture pressure, level, speed, temperature, flow. Sure. All these process variables pH, are like super useful to you. It's just noisy and it's buried under a lot of how do you slice and dice that data? Right. So building a technology which can look at it from a SKU level to what you are making to how you're making and understanding these patterns in these parameters
Right.
is the key.
Got it. Yeah, I think back to my years in the metal finishing or surface finishing industry for 10 years. I ran the biggest metal finishing contract manufacturer in the country, 16 automated lines. And every one of those lines had, call it 40 stations on it. Almost every one of those stations had its own PLC.
Yes.
And when we would have a process control issue, whether it was a color wasn't right or the thickness that we were putting on the particular part wasn't the proper amount of plating thickness, for example, you could go days trying to analyze that and figure out, connect what the root cause of that problem was and solve that problem. And from the time you identified the problem to the time you actually solved it. And so let's keep going now on the conversation, in any one of those applications. So now, I'm a manufacturing engineer. I'm a vice president of operations. I'm a general manager. I'm running a manufacturing plant. I probably have efficiency and yield and throughput problems I don't even know that I have.
Correct.
And now I'm leveraging Golgix's software or your technology. So I've got this data at the PLC level. What happens from there as it goes into the API and how do you analyze and utilize that data?
Let's talk about it in terms of the use case, right?
Yep.
For all the use cases, one thing is consistent is the methodology.
Yep.
So once this data comes into our software, it gets cleaned. When I say cleaning, the job is to separate the noise from the signal.
Okay.
So all duplicate entries, null values, bad values get separated. And then the signal goes into our pattern recognition engine, and it's simple traditional AI engine which looks for patterns leading to an event. An event could be a quality loss, speed loss, or a throughput loss, or a machine failure.
Sure.
So these specific events, leading indicator in the patterns leading to that, so that the next time when these pattern, the earliest sign of the patterns come up, it can make that prediction to this is what happened last time. Again, probabilistically, not deterministically, because nobody can be deterministic in this model. Right. So giving you the top 5 things which this pattern has resulted in what type of failures.
Sure.
Historically.
So are you training the AI on an ideal scenario and then having it find anomalies from the ideal scenario, or how does that work?
Basically, it's a training. We put all the data through our engine. It knows what good looks like. So what the best efficiency point when you hit peak throughput, peak yield, what the good looks like, and they also know what the bad looks like when you hit the sub 60s and sub 80s numbers. So it separates those two data sets accordingly, and then learn what the good trend line looks like and what the bad. So it always predict what the good should be, and then the actual reading comes in real time to compare what the delta is, to tell you how far you are from the optimal state or what you should do to catch back up.
Yeah, it's really, a lot of ways, it's almost like automating Six Sigma, right? So you're finding variation from a standard process once you've established what that ideal process is, and then creating an on signal of some sort, or a wake up call for the engineer, the operations manager to respond to whatever that challenge is. So I want to take a quick breath here and just mention for our manufacturers that are listening, and for those that participated, for instance, in this latest survey that we did, or just sitting in their manufacturing plant saying, I know that AI is something that I need to be using. I know that this is going to change the world. I have no idea where to start. What I'm hearing from you is, if you have PLCs on your manufacturing plant floor, which is 99% of all manufacturers, you're already in some ways collecting data that can be leveraged using artificial intelligence for continuous improvement. Is that right?
100%. Just give me a call. That's all.
Yeah, awesome. So let's exactly. Just call Nitin. So, and before we get a little bit deeper into the execution and the implementation of the technology, so now we've got that data. Now we're finding the patterns. So I'm whether it's a plant supervisor on a shop floor, whether it's somebody that's working in production planning or operations or maintenance or what have you, how are they interacting now with the platform? What information are they getting? How are they getting it? How are they being alerted if there's an anomaly?
Yeah, no, that's a great question. And that's what we are consciously optimizing for, because adoption is key for any technologies. And what we are learning is that not everybody wants to look at a screen 24/7. So we have a web interface to the application. You can log in and watch it. But what we're doing is, depending upon your top loss drivers, which changes, by the way, on a monthly basis, your alerts are dynamic. So depending upon what the top loss driver is, what we have seen that the top priority what manufacturers have is hit their production target.
Right.
That's literally all they care about. So we take that as our North Star metrics in our solution, and if you're missing it by 5%, 10%, 15%, depending upon what you set the threshold, depending on the manufacturing process, it notifies the user group.
Right.
So it could be an engineering group gets notified at a 5% miss. VP and directors get notified when a 10% miss.
Okay.
A C-level gets to know when it's a 20% miss, right? So it can really go through that, the level of analysis, and then provides you with where to look.
Right.
Do you look at a machine? Do you look at a line? Do you look at a process? Do you look at a quality? Who to call?
Yep.
Only 4 things can go wrong. You're going to make bad parts. You're going to make it slower, so engineering issue, or you're going to have machine broken, so maintenance issue,
Yep.
or it is just an operator is not loading on time, so operations issue. So it just gives you at a glance where to look quickly and try to find the solution for the problem instead of like just calling a meeting for everybody involved.
Yeah, and I'm going to date myself a little bit by telling this story, but I was part of a team that acquired a company now almost 20 years ago, believe it or not. And the seller of the company and I were traveling to a couple meetings to meet the biggest customer. And I had the earliest version. I was like the first person on the planet to have an iPod, right? You know, it was the one that used to transmit to the radio in my car,
Yep.
believe it or not. And I was just dialed up a song, and he's like, and then I dialed something else up, and he's like, well, how'd you do that? And I said, well, I have this iPod with all this music on it. I just, you know, like any song you want. I'm like, well, yeah, anything that's loaded on the iPod. And his question, which is my same question for you, he said, well, why wouldn't everyone have one of those? And I'm like, well, I think probably everyone should. And of course, now everybody does in one form or another. The solution sounds so logical and so obvious.
Correct.
Why wouldn't everybody be using this?
I think
Story of your life, right? Or a question of the business. Yeah.
You know, this is a question which I think we have been trying to optimize against ourselves. And what we are learning is, you know, AI systems in general, everybody wants it, but they don't trust it.
Right.
And to trust it, you need to trust your data.
Mm-hmm.
And there's a perception, which we go back to the beginning of this
right.
podcast, where, hey, people don't trust their own data. So in order to them to trust the output, they have to trust the data. Literally, our product can be deployed in 2 hours.
Wow.
But when you go out and you see on our website, it says 8 weeks. That's for a reason. Because the trust, we have to build the adoption, we need to build the trust.
Right.
So we make sure we help manufacturing engineers or operations, you know, technical, non-technical, both users, go through the process of building that confidence in their own data, which
right.
we have harvested or mined and cleaned, so that they know that whatever outcome comes from the solution is powerful, is something they would want. And that is why I think the adoption has been slow, where people have been being a little bit, one of the executives told me recently that we have been over-promised and under-delivered so many times that
right.
we take everything with skepticism.
Yeah.
And so I don't blame them. So that is if we can restore the trust in their own data, I think we can solve this problem.
You obviously you're going to know right away once it's implemented. This isn't something that's taking 12 months. You can walk in, and once you've got somebody excited about the technology, you execute on it. You show them value right away. They know whether or not it's something that makes sense. There's no place for you to hide either, by the way, which can be a little bit of a scary situation as a supplier. I've been on both sides of that, but that's how we drive performance, and that's how we drive rapid improvement in manufacturing. No excuses. Here's the solution. Let's make it work. Let's show the use case. So speaking of those use cases, do you have a specific client? If you can't name the name, I understand, but do you have a specific example that would resonate with our audience of somebody that's used this?
So for a continuous manufacturer at a food and bev, you're talking about, think about an extrusion process,
okay.
right? You're making food products at a pressure 6,000 psi.
Okay.
It's not, to make a good quality product, you got to maintain that pressure.
Yep.
But what really matters is how you get to that pressure. One of my customers was having 71% of their downtime related to high pressure, blowing valves, tubes, and no matter what, right? And they were always scratching their head, be like, our CapEx bill is through a roof,
right?
Close to $1 million, yep. And I am.
So they're spending $1 million on hardware and
repair,
yep.
and just repair, just catching
yep.
up, because their operations team was flying blind. They didn't know the way they were getting to the 6,000 psi was they were getting to a failure point much faster. Because after that point, if you didn't set up the machines correctly, you're going to get to 11,000 and you're going to have a high pressure failure right away.
Okay.
And that's going to take days for it to come back, right?
Sure.
So now with our technology, they know that the way the back pressure, the way the flow, the way the conveyor speed, everything is set up, are they getting to the pressure correctly?
Okay.
Or not?
Got it.
And gives them a 9 to 32 hours advance warning before that failure happens.
Wow.
So giving them that confidence that they're not flying blind anymore.
Right.
And they're not hurting the machine in the process.
Right.
So their capex is down by 450,000, and also a year. The annual numbers, and their downtime is down by 59%.
Yeah, so to put that into perspective for anybody that maybe isn't quite as up to speed on all the manufacturing lingo, again, CapEx is capital expenditures. Those are your non-operating expenses that you're spending on capital equipment every year, and so you're making an investment. And what I'm hearing is that rather than spending $1 million a year on capital expenses, or CapEx as we call it, for those types of problems, that number's down now over half, right?
Correct.
To 450,000, is that what you said?
Correct.
And then the efficiency improved by, give me that number.
59%.
59%.
The downtime efficiency. Yeah.
Okay, got it. So you're producing in some cases 59% more product than you were before in the same period of time. Yeah. Which is now creating all this extra capacity. And when we have downtime in manufacturing, of course, you're paying a team of people to run that manufacturing line, whether there's anything coming off of it or not. You're heating the plant, you've got lights on, whether there's anything coming off of it or not.
Utility.
So all of those expenses are going right out the window when the machine isn't running. And you're saying we've been able to resolve that issue to a large extent as well.
Yep.
Just using this tool, just
using the existing data. They use Factory Talk Rockwell. They have all this data sitting there.
Yep.
We just took that data, elevated it into our platform, and gave them that prediction.
Yeah, there you go. So Rockwell Automation Factory Talk, which is the software that we're using in many cases to oversee manufacturing equipment and monitor programmable logic controllers. You're pulling the data right out of there and doing the analysis. That's awesome. Let's think about this. We've talked about the types of data. We've talked about some applications and use cases. Other challenges that you have in terms of working with somebody. So part of it was like they don't trust their data. What about somebody that has, even if they don't have perfect data, it sounds like this is a great application. But I've got the data, I've got the solution, I've got the team that's ready to implement. But I'm like, you know what? I've got all these concerns about cybersecurity. We have our secret sauce. Nobody knows how we do X, and that's really, that's a key thing in manufacturing. And I've run manufacturing companies where it's like our ability to generate margin was because we could do things nobody else could, because we had intellectual property and subject matter expertise nobody else had. Putting all that data out on the cloud, having somebody look under the hood of our manufacturing process and know exactly how we're doing it, which is basically what you're doing when you're engaging with these clients. Is that a concern or an impediment to execution?
Absolutely. I think I have known this for 20 years because I used to work in this industry where I've seen that nobody wants their data to help the competition.
Uh-huh.
And that's the reality. And so we built our technology agnostic to that requirement. If you're not comfortable in going to the cloud, we deploy our technology on-prem or in your private cloud.
Interesting.
Because we don't want to be liable for the ransomware either. Yeah. Because nobody wants that. So to deploy our technology, IT doesn't have to change any policy on their end, number one. And number two, we deploy our product where your data lives today. Okay. So your data doesn't have to go out anywhere or leave the safe space it is in right now in order to use our technology.
Interesting.
The only thing which we have opened up today is our large language model, where a non-technical user can ask a question in natural language. Even that we have made it in a way that your data never leaves, only a question leaves to our large language model, gets converted into a SQL program, comes back on site, inquires the data there on-prem, and gives you the output.
Any other challenges you hear from clients in terms of this is the reason why we're scared of doing this or afraid of doing this? What are some of the things that are standing in the way of AI?
I think the AI has just gotten a bad rap about how complex and how difficult it is to implement. And every time I go to a manufacturer, they're like, how much of my resource time are you going to take? Mm-hmm. I have all these priorities I got to get done. Right. And how much are you going to add on to it? And that, I think, has been one of the reservations where people are starting to understand that it doesn't, the providers in the market have a hardware layer, a software layer, and a services layer. To deploy all that, it does take 12 months. And it might be a little bit resource intensive. We are not that company. So we are trying to help them understand that all we need is 1 hour of your manufacturing engineer's time every week for the next 8 weeks.
Right. Eight labor hours, right?
Yeah, eight labor hours.
Wow.
For them to understand how the system works.
You started that answer by saying that people they're so afraid or they have no idea the resources that it's going to take, or they're overwhelmed, or where do you think that perception comes from?
Somebody gave me this analogy. manufacturing, and you have ran so many manufacturing companies, so you can maybe relate to this. A manufacturing is a boat with bunch of holes in it,
Okay.
and you're constantly pulling the water out of
Right.
it,
Yeah.
right? And I think nobody has given them the ability to understand which hole in the boat is bigger than than the other.
Yeah.
So if the perception change that if I can find the biggest hole in the boat and plug that, I
Right.
need to do less effort in pulling the water out of the boat.
Right.
That's the technology we are providing. But I think throughout the years, the technology available to them has been, how can we make the water come out faster?
Huh.
So they always think it's a
Yeah.
resource
I
intensive.
need a bigger pump,
Yeah.
not a smaller hole.
Exactly.
Yeah.
Exactly. So they've always been thinking about how to throw more people at the problem, we'll solve the problem.
Right.
How to add more automation in the plant, we'll solve the problem. How do we add more pumps, we'll solve the problem.
Yeah.
What we are saying is, actually, let's find out of all the hundreds of holes you have,
Right.
the biggest hole and plug it.
That's really well put. I
Yes.
like that. Now I'm thinking about if I'm an operations manager, an engineering manager, or a general manager of a manufacturing plant, whatever position they're in. So I think sometimes people don't recognize in the world of manufacturing. First of all, if you're in a leadership position, there's a good chance your plant is running a lot while you're not there, right? So, I ran plants, honestly, that ran 3 shifts a day, 6 days a week for a while. I wasn't there 24 hours a day, 6 days a week. Mostly I might be there, 10, 12, 15 hours a day, but then the other hours of the day I wasn't in the plant. And I tell people who haven't worked in manufacturing, and there's other spaces that are like this, but you're always 30 seconds away from your next disaster. In other words, and I've had these things happen to me, you never know when, your phone is going to ring in the middle of the night, or you're going to get a text during the day, and there was a fire in a plant. I had that once, that wasn't a fun thing to live through. We've had, unfortunately, some safety issues with folks that ended up in situations. Yeah, absolutely. None of them fatal, fortunately, but you hate to send anybody home from work, in less than perfect shape. So you have issues like that relative to, workplace accidents and so on. You've got things like customers screaming for expedites, or an order that got to a customer that was 500 miles away and it's out of spec, or, not that those were the norm, but they always happen and you never knew when that was going to come at you. So for the people that don't work in manufacturing, if you're in a leadership role in manufacturing and operations, that's the life you live, right? Is you spend every 24 hours a day, never 30 seconds away from your next disaster. You're never completely off the hook and you're never completely unplugged. So no, I'm that person. I'm the person that's responsible for this manufacturing operation. I'm doing a bazillion different things. And now I've got the Golgix solution implemented and executed on my shop floor. How am I interacting with that? Is this an app? Am I sitting in front of a PC? Is there an alarm? I mean, tell us about how that works.
Yeah, so it is all of those things. It is a PC web application, so you can pop up an application. You do have to get a VPN because you are going in your company's network to access it.
Yep.
Or it can be a phone. Like we also have a phone app, so you can download it in the phone and you can access this data there as well. We have really focused on user experience because I think manufacturers don't have the modern stack of technologies today,
right?
And we are trying to bring that to them.
Sure.
Because why should they not? They don't have the same digital experience they get by using their personal applications, which they use outside of work.
Right.
Why there should be any difference, right? So I think that has been one of the reasons why I believe the labor challenges, shortage challenges we are facing in manufacturing is part of it, because it doesn't stimulate them on a digital basis.
Yeah.
So we are trying to solve that by using modern technology, modern stack to give them that experience and interface.
And let's pause on that for just a moment, because I think that's a really interesting point that I hadn't considered before. But, I was with a manufacturing company in the last year that's still using an AS400 platform for their manufacturing, their MEP system.
Yep.
You still see quite frequently green screens on manufacturing floors, right?
Oh, green screens, HP, Dell, all TV type of computer screens.
Absolutely. And so you're thinking about that. That technology was around in some cases in the late 80s and early 90s, right? And in some cases we're still using those to run our manufacturing floors. And what you're telling me is that one of the challenges in finding people in manufacturing is that they walk into a manufacturing floor and they see this antiquated technology and they're like, well, wait, I got 1,200 apps on my phone that I can access to do all these different things. And I walk into this plant and they're using stuff that was, created 15 years before I was born. And that's a challenge. Huh?
And, for a young professional, they don't want to work with a stack, which is going to take them back in time.
Right.
They want to be ready for the future. So they want to come in and say, like, you know what, I'm not only here to deliver my service, but I also am here to learn something.
That's awesome.
But if you're giving something which is 15 years old, you're not teaching me much.
Right.
You know what I mean? So
yeah,
I
no,
think,
that's a great. I want you to keep going with the answer on the user experience, but
yes.
that's a. I just wanted to call that out because I hadn't heard it explained that way, and I think that's a really interesting observation. Go ahead.
So I'll tell you, like, I know you shared your story, but my passion for what I'm doing today comes from my father. He was a manufacturing executive back in India. He ran a steel manufacturing plant for 40 years.
Wow.
And all my learnings has been driven by how I have seen him. Like, he didn't return home 3 days in a night sometimes,
Yeah.
right? He has missed birthday parties. To your point, he will get that time he used to have a pager. The
Yeah.
pager will start beeping and he
Right.
has to run back to
Yep.
the plant. What was the issue? 3 days later, 72 hours later, a valve in some corner start to malfunction and
Right.
nobody had. So the data was always a thing which is solve the problem. But also, how do you make that intelligence come to you, delivered to you, is a key component of that.
Right.
In the last 10 years, the IoT industry 4.0, I think the biggest challenge what they did not solve was they thought that if I measure everything, if I get all this data, the solution will become evident. That is not true.
Right.
You still have to make sense of that data
Yep.
and deliver it in a way that it is digestible for people. So we use things like least number of clicks to get to an actionable intelligence.
Okay.
We have learned from manufacturing experience that they don't want alerts after alerts every time. Only if the problem gets worse. So when we talk about the lens, I think the biggest challenge in the manufacturing floor has is the priorities. How do I prioritize which problem to solve first? So when we look at it from the ability of hitting my production target, and whatever is getting in the way of that should be my priority. Not everything else I got cooking in the back burner, right? So we prioritize that through our software, provide an alert, really focused on those type of issues, and then give them a weekly roundup of all the things what they should be looking at in order to make their life better. So phone application, email notification, text messages, and a web application for you to log in.
Sure. And discerning so that you're not overloading them so much with information that it becomes like the little boy that cried wolf, right? That
Correct.
you're only notifying them when there's actually an issue and that there's something actionable that they can be doing around that. I also just want to briefly go back to, we a lot of times think about, with companies, what's your why, or why do you exist, or some would say that a company's mission is their the reason that they're in existence. And in some ways, your why, and I like the way you characterize that, growing up with a father that worked in manufacturing all those years and was providing for his family and obviously created an incredible future for his family, but missed a handful of those things, or maybe more, because of the draw of manufacturing and the fact that, the manufacturing plant doesn't wait for the birthday party to end, right? Doesn't wait for the clown to show up, right? You gotta go in and solve that problem. And in this case, part of your why is helping individuals working in manufacturing free up some of their day, whether it's in the plant or out of the plant, so that they create a more predictable model, they have fewer surprises, and they have a better quality of life. Is that true?
100%. We are not building a technology just for business value. We are building a technology for people.
Mm-hmm.
For the last 20, 30 years, we have seen smarter machines. We have seen more automation.
Right.
We have seen better processes being implemented. But what we have not seen is an investment in people and how they're getting asked to use a B2B software. Like, we are a B2B company, but we think like B2C, because ultimately we got to win the hearts and minds of people using our technology, not just business case. Because once they start doing it, their life is going to get better. The most important challenge which I have learned in my entire year is the plant floor is full of chaos and uncertainty.
Mm-hmm.
To your point, 30 seconds away from a disaster, right?
Right.
And that fear, just think about what that does to your...
No, I don't have to think about it. I lived it for 25 years, right? Yeah.
And I saw it through my father.
Right.
I saw it, how it changes his behavior, his planning for his personal life, right? Nobody should live like that. So building this technology which gives people that foresight and control, and it's not difficult. The point is, it's not difficult to do that. It's just have an ability to understand what is your priority, which is the biggest hole in the boat. How can I plug it in, right? Those are things, if you give them that, everybody knows the issues are always going to be there. But if I can slow down and provide my team some more space and some more time to act on it, everybody can do some creative work. And that is a technology we are trying to build. And our why is to make people less stressed, make people less uncertain, not always chasing. Like, you go to a plant for today, you'll see people just running like in a fire brigade mode, like there's a fire everywhere, and we're just trying to solve that problem.
Got it. So let's talk. You mentioned earlier about the the concept of certifications, the concept of upskilling, training people around artificial intelligence. You and I have talked extensively about some of the initiatives and endeavors that I've been involved with, everything from K-12 to technical college, universities, workforce around artificial intelligence, and creating an AI literate workforce that can interact with artificial intelligence, that understands how to bring it to bear, how to apply it. That's a big thing for me, is applied AI. I'm certainly not an expert on the software side, but in terms of how do we take artificially intelligent platforms that others have developed and put them to work in organizations. I've done a fair amount of that, but that doesn't happen without a workforce that it is at least open to and understands the applications of some of these technologies. So talk a little bit about that as we prepare the next generation of the workforce for how artificial intelligence is going to impact the world of work, and what skills are most important for them to possess as they thrive in this new era of whether it's manufacturing or food production or really any segment of the economy. Talk about that.
So for me, the important part is how do we get people finally excited about working in the manufacturing floor.
Right.
And it's about giving them the control and the foresight of the data. And so we wanted to help manufacturers not become an engineer to adapt a technology, but be anybody, technical, non-technical, still adapt a technology and then learn from it, right? So the certification program which we talked about is how do you get an engineer who's good at looking at engineering design problems and things, but might not be that good at interpreting data. Right. So how do you make a software? First, tell them to trust the data. So there is a process which we take them through how 5 or 6 quick ways of testing a data.
Right.
To build the trust. Right. We show them that, we automate that function for them, and they're good with that. Then we take them towards like when an information comes to you, how do you process it in terms of like what to look out for? Like whether this is an actionable intelligence or it's just an insight. There's a difference between the two.
Right.
How do you interpret that? What else you need to query? So a lot of that is by creating a closed loop system. And then finally, our fact finder, which is our large language model, people are using it to say like, okay, the AI system told me this. The best way to test an AI output is to ask the question back to the AI and see if it comes out the same answer.
Yeah.
And that is how we're training people to like build the trust. Be like, AI is there to serve you, not to test you.
Right.
And when people learn that, the value of the data, the value of data-driven decision-making, I think that will change a lot of that. We are working with universities like UW-Milwaukee, WCTC as well to help them.
Waukesha County Technical College, by the way. Yep.
Yep. To get our technology in their labs. So the students who are tomorrow's, manufacturing operators, they can access to something like this, and they know that they don't have to always rely on experience and gut. You can use the data to make informed decisions.
Absolutely. Making informed decisions, driving productivity, improving yield, all these other great things that happen in manufacturing. I know we've got manufacturers that are listening and saying, this all sounds great, but what's it going to cost me and what's the ROI? What can you tell just a, kind of a order of magnitude about what something like this might cost to invest in?
The price definitely vary because we serve from small manufacturers to all the way to lower and enterprise customers who don't have data science teams. So typically a manufacturer pays close to $9,000 a year for a line.
Okay.
And with that, the ROI we have seen for manufacturers, which we have been our customers for a while, sub 3 months to 5 months ROI.
Awesome. Yeah. So you're talking about you're rolling the dice with $9,000, which for most manufacturers isn't pocket change, but it's doable. And you're going to know within 3 months whether or not this is something that's adding value. For those that may not be perfectly familiar, if I'm investing $9,000, I'm going to see a $9,000 reduction in CapEx and operating costs in the first 3 months of that period of time. So, I mean, that's the ROIs. I used to say in manufacturing, I would get excited at anything that was 18 months or less.
Yep.
If something was more than 18 months, I could always find something better. But in this case, you're saying literally 90 days, we could be right side up.
When we started this thing, we said we'll only do business case or values or customers where we can do sub 6 months, because anything above 6 months, the speed to value gets challenged. And it's one of the top principles of our business. If we don't deliver value at speed, we are not an AI company.
Yeah, that's a good value at speed. I love that thought, and that's a great way of putting it. I've got Want a quick, like 2 or 3 sentence answer to make sure we get enough time for our last question on this next one. But give me some sense of, if I turn the clock forward 5 to 10 years, Nitin, what's some AI-backed solution, or what is the world of work going to look like? Blow our minds a little bit and tell us what something that you think is coming.
I think American manufacturing, if you look at the whole thing, and I think you are also, a lot involved into this,
for sure,
even more than we are right now. But I think the objective is AI is going to get adopted by all businesses, not just manufacturing.
Right.
And the competitiveness would be, how do you use that in terms of solving your problems faster than anybody else, getting to value faster than anybody else, delivering value to the ecosystem. So I think the use of technology, people would stop doing menial tasks, like the repetitive task, which we can automate and would have taken 4 months, 6 months to do an RPA, automate the whole process, will take probably a week or hours to do that, right?
Amazing.
That will really put some gas there. And finally, what I see is people spending more time doing creative work, challenging the boundaries, challenging the envelope, saying like, okay, how can I change the product design better? How can I make it more sustainable? How can I make it more less carbon emission? Those type of real world use cases, which right now manufacturers on a mid to small segment don't even think about. If you ask them, what is your CO2 emission? They don't even know that.
Most don't, right?
Yeah, because they don't have the requirement to test it. But I think those are the real world challenges which will become something everybody will be evaluated on. And you can only do those things if you can take everything which you've been doing for the last 20, 30 years and automate that using AI, because building a same spreadsheet over and over and over again is not something anybody likes doing.
Right. Yeah. At some point, that repetitive work gets a little bit dull. Let's get into the creative side, which requires a whole new set of skills, which is why it's so important that we dive all the way back to our K-12 students and get them excited about these kind of technologies as early as middle school, but certainly by high school. And I want to think about that high school period of time as I pose our last question to you. Nitin, you mentioned, grew up in India, father working in manufacturing. Now you're here in Wisconsin running this awesome technology company. But if you had one piece of advice to go back and offer to the 15-year-old version of Nitin Ranjan, so if you could tell that young man one thing, what would that one thing be?
Coming from India, we are the highest population, in the world as a country. Coming second or even coming outside top 5 is not an option. If you are there, if you're not the first, you're not going to get the next best opportunity. And throughout my high school period, I always focused on the results because the ranking system, number one, right? And I never became top class, ever, never. I was always in top 10, but never in top 5, which mattered.
Yep.
And focusing on the results, I beat myself over that and never really enjoyed the journey or the process.
Yeah.
But guess what? Today I'm sitting here. I'm happy with what I have achieved.
For sure.
I never went to any Ivy League school or never qualified for the top universities in India.
Me
but went with the flow.
Right.
Well, whatever came to me, I embraced it, worked on it, did start early, did take risks. All that is true. But what I did not do back then was always worried, never enjoyed my journey. Because knowledge acquisition, the journey is beautiful. I think if I go back, I would enjoy that phase instead of worrying about the results, because I did fine. I'm fine, at this point. I'm not an IITian, which is a big deal in India, but I'm doing better than most IITians.
Interesting, fascinating. So enjoy the journey, spend a little bit more time in the present moment, recognize that things are going to work themselves out. I'm glad we took some time to enjoy the journey of Golgix today with Nitin Ranjan, talking all about the background of the company, incredible AI-backed software that is doing amazing things for manufacturers, not just the companies themselves, but the people that work there. And Nitin, I want to thank you so much for joining us on the Tech Ed Podcast.
Thank you, man. Thank you for having me.
And thank our audience as well for being with us on this episode of the Tech Ed Podcast. So much interesting information that came our way from Nitin Ranjan, and we will link all of those topics up in the show notes for this particular episode. You can find those at techedpodcast/Ranjan. That's techedpodcast/RANJAN. That's where you'll find the best show notes in the business. You'll also find us all over social media. We are on Instagram, on TikTok, on Facebook, on LinkedIn, and the list goes on. We would love to hear from you, and we would love to see you next week on the Tech Ed Podcast. Until then, I am your host, Matt Kirkman.